So what about 38? Natural log.
What page?
Yes, good. Thank you. Oops, 501. X to the fourth, the square root of x squared plus 3, everything divided by x plus 3, everything to the fifth power. Is this what you had in mind? Close or? Okay. So I look at this expression and I see basically three quantities here, three factors. Would you agree? Would you agree with three quantities? Okay, these two are at the top. So when I expand the log, what will be the sign in front of that particular log? The answer is positive. So natural log of x to the fourth plus natural log of the square root of x plus 3. Now this quantity comes from the denominator. What will be the sign in front of it? Obviously it cannot be positive because the top have positive in front. It will have negative. Negative log, oh, I'm so sorry, natural log in parentheses, x plus 3 to the fifth power. So if you remember, it's a good point, very good question actually. So this is what we said last time. If a quantity comes from the top, log will have plus in front. If the quantity comes from the denominator, the log will have negative in front. Is that okay so far? Stephen, you had something?
Yeah.
Okay, so now the power rule requires us to put 4 in front as a factor. And the square root is what power? Half, very good. So 1/2 natural log of x squared plus 3. The square root and power 2 cannot be the same, right? Square root is power 1/2 and power 2 is power 2. Okay, so then minus 5 natural log of x plus 3. I want to caution you on these two. We do not have a log, there is no log property when we apply log to a sum or a difference. You cannot simplify that in any way, shape, or form. We only have three properties: log applied to a product, log applied to a ratio, and log applied to a power. We don't have a property for log applied to a sum. This is it, fixed. Okay, so sum or difference cannot be simplified. Is this what you had in mind? Is there anything else you wanted to go back to?
Well, if we use the 4, instead of using x raised to the 4,
Yes.
it's going to be the 4th root of x squared plus 3. Something very similar.
Oh, you want to create another example. Okay, so you want natural log of the 4th root of, what do you want inside? Okay, so let's say x to the 3rd y over x plus 1. Okay, so first of all, what is power 1? What is the 4th root? What power is that? Correct. So this is natural log of x to the 3rd y over x plus 1 to 1/4. The first property that needs to be applied here is moving 1/4 in front. And then let's see what we have in brackets. I see two quantities at the top and one quantity in the denominator. So what will you write? Natural log of, okay,
Minus natural log.
I agree. Then we have to move 3 in front and distribute 1/4. So 3/4 natural log x plus 1/4 natural log y minus 1/4 natural log x plus 1. Very good. And that's the end of it. There are no more properties to apply here. We applied everything we could. There are only 3. Very good question. Is this okay, everyone?
How do we get 3 4?
Put 3 in front and distribute 1/4. Is that okay, everyone?
You can give them for just a
Oh, yes, of course. I'm not changing anything. Okay, I would like to continue with one other type of exponential equation. So let's say 41 on page 514. And that is 5 raised to 2x plus 3 equals 3 raised to x minus 1. So my first question to myself is, what type of equation is this? It could be absolute value, quadratic in form, linear, square, square root, polynomial, rational. What is it? Of course, the variable is only at the exponent level. It must be exponential. Awesome. So then my next question to myself is, can I present 5 and 3 with the same base? Of course not. So that's not an option. Perfect. Then what is the only option? The only thing that I can apply here to both sides is natural log. Because only natural log allows us to bring the power down. So 2x plus 3. If I omit to put parentheses, I mess up the problem. So 2x plus 3 natural log 5 equals x minus 1 natural log 3. Is this clear? We apply the power rule. Is this okay, everyone? Mm-hmm. Good. Now, please, I know that these numbers look weird or they look intimidating. Please don't get intimidated by this. It's a number. If you want to see it, I'll plug it in, natural log 5. It's some number, whatever that is. Natural log 5. It's this. We don't care. It looks fantastic, right? It's natural log 5. It's not 1.609. So don't get upset or, scared by it. Don't worry about it at all. It's just a plain, simple number. So now I see that I have x here and x here. I'm trying to solve for x. What will be my next step?
Oh, we weren't.
Say it again.
I don't know we weren't doing.
No, we haven't solved for x. The equation at the bottom, at the end, has to have x equals and only numbers on the other side. We are solving for x. Good. So what do you recommend next? Of course. I'm distributing this number to these two terms. Very good. 2x natural log 5 plus 3 natural log 5 equals x natural log 3 minus natural log 3. Indeed. Perfect. Awesome. I have to distribute. Perfect. Next step. Remember, I have x here, and I'm solving for x. Go ahead. I'm sorry. I cannot. Remember, I cannot solve if I have x on this side and x on this side. I can do that.
Can you show me you distributed that?
This times this is this. 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 Better?
Yeah.
Good. This is x and some numbers. Obviously, this is a linear equation. I have to change and move the terms around so that I have x on one side only. 2x natural log 5 minus x natural log 3 equals negative natural log 3 natural log 5 minus natural log 3. When we solve a linear equation, terms with x have to be on one side. Terms without x have to be on the other. Good. Now what? Now you would say combine like terms, but I will have to say I cannot. If I cannot combine like terms, there is an alternative. What is the alternative? And there are two key words in algebra. One is awesome, and the other one?
Factor.
Awesome. Which one works here? Of course. What am I factoring out? Of course. Of course. Awesome. Thank you. Well done. So what is left? What is left in parentheses? Yes? 2 natural log 5. Awesome.
minus natural log 3.
Very good. Thank you very much, Stephen. And now I want x. I'm done. This is final. What do I need to do to get x by itself from this? Again, do not get intimidated. This is just a number. I will divide both sides by this number that multiplies x. It's a linear equation. This is just a number. Negative 3 natural log 5 minus natural log 3, 2 natural log 5 minus natural log 3. This is the exact. If you want to approximate, we can do that with a calculator. If it's a word problem, we will need to approximate. If it's an equation, the exact solution is perfect. Would you like to approximate this to see what it is and check the solution? We do? Yes? Okay, perfect. Let's do that. So do not forget parentheses for the top. Parentheses for the top, negative 3, natural log 5, close the parenthesis, minus natural log 3, close the parenthesis, and close the parenthesis for the numerator. So there's a parenthesis on the left and a parenthesis on the right, only for the numerator. Now divide. Left parenthesis, 2 natural log 5, close the parenthesis, minus natural log 3. Do not try to simplify anything. That would be wrong. So I got the answer is negative 2.795, approximately. 2.795. I go back to the original equation, which was, yes, just one second. I just want to copy it because I'm going to go back to the. Okay, so now I'm trying to check. So we had 5, caret, in parentheses, 2 multiplied by the previous answer, and then plus 3. Close the parenthesis, and then minus 3, caret, in parentheses, the previous answer, minus 1. Okay, so I'm checking negative 2.795. When I hit enter or put enter, press enter right now, what should I get if this is indeed negative 2.79? Correct. Awesome, correct. If I don't get 0, the solution is incorrect. So one more time, this is the exact, and this is the approximation. We did not use the approximation to check. We used the entire number because we recalled the previous answer. Is this good enough, or you think we need another example? One more. Perfect. Okay, there is another problem, which is 42. On the same page, 514. And that is 7 raised to 2x plus 1 equals 3 raised to x plus 2. Okay, let's work on this problem for 1 minute and then do it together. And then we'll continue with log equations. Okay, 2 minutes. What type of equation is it? Very good, exponential. Can you present both sides with the same base? No. So what are we going to do? Exactly, which is?
Make it a natural log.
Yes, apply natural log to both sides. That was cute. If you need help, let me know, please. Okay, ready? So our only option is to apply a natural log to both sides, is to copy the power in front, applying the product rule. Natural log 7 equals x plus 2, natural log 3. Then, yes, then we have to distribute.
Oops.
And remember, this is just a number. Don't be afraid of it. It's just a tiny number. It looks sophisticated, but it's really not. 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. Next step, please.
Factor.
Not yet.
Oh, wait,
Combine.
Yes. So I have 2x natural log 7 minus x natural log 3 equals 2 natural log 3 minus natural log 7. Next step obviously would be to,
Factor.
yes, what am I factoring out? Indeed. So then 2 natural log 7 minus natural log 3, 2 natural log 3 minus natural log 7. And the final answer would be, and now you know how to check this over this. And you cannot simplify anything. Do not attempt any simplification.
Is it wrong if you put negative natural log 7 plus 2 natural
No,
log?
because 2 minus 3 is negative 3 plus 2. You will get the same answer. Okay, so what did we say, if you remember? Yes, please.
Quick question.
Yes.
When did that 3 become positive? Was it a negative?
So there is no 3. You're talking about natural log?
No, because it wasn't it 7 2x to the power of 2x plus 1 minus 3.
Yeah, I thought it was minus 2, but it was an equal sign.
Oh, it's an equal sign. Oh, okay, never mind.
That's okay.
Everything's gonna work
No
out.
problem, no problem. So what did we say about the exponential function? Is the exponential function friendly?
Yes.
Yes, it's defined on all real numbers. That's why we never had any restrictions to write when solving exponential equations, okay? What did we say about log function? Is log a friendly function? No, log is not a friendly function. So let's look now at log equations. We will have to state restrictions like we did with the rational functions, rational equations. Okay, here's the first equation, but before we do that, we have two options. I'm not telling you which option to choose, but you have to choose one. You don't have to be consistent. If you get 3 problems that are the same, you can use option 1 in the first one and the third one, and option 2 in the second one. It's up to you. But you must use one of the two options every time you solve a log equation. What are the options? For option number 1 is check solutions. Back in the original problem, of course, back in the original equation, like we did with radical equations. Remember when we squared both sides, we got 2 solutions, or 1 solution, and we went back to the original problem to check. Same thing here. I personally don't prefer this, so I'm not going to use it, but you feel free to use it. Second one is state domain. I prefer this for two reasons. One, if I use this method, my students tend to remember how to state the domain or how to find the domain of a log function, which is very important. Secondly, I don't want to forget to check back in the original problem. I may forget. But if I state a domain, I will not. Most probably not, I should say. And it's easier. Three reasons. It's easier to state a domain, I think, in most of the cases, than go back and struggle with checking the solution. Okay. You feel free to use the first one if you want to. So here's our first equation. Problem 60 on page 515. Log base 2 of 4x plus 1 is 5. So if we state the domain, what would you write? How do I determine the domain of this function? What has to happen here for log base 2 of this to exist? No. Say it again. Yes, 4x plus 1. This quantity, 4x plus 1, must be greater than 0 for the log applied to 4x plus 1 to exist. If this number is not a number strictly greater than 0, log doesn't exist, is undefined. So then I have 4x greater than -1 and x greater than -1/4. So that was not a big deal. Thank you very much. So the domain is -1/4 to infinity. When I solve this equation, if I do not get a number strictly greater than -1/4, I'll say the solution, this equation has no solutions. If I get a number greater than -1/4, then I'll say that's the solution or solutions. Okay, so that's the reason why I said there is what I think it is the most important concept in this class, in this chapter. What is it? Any log equation can be replaced by an exponential one. Very good. Always start with the base and go counterclockwise. The base raised to 5th equals? Excellent. 2 to the 5th equals 4x plus 1. How much is 2 to the 5th? Very good. Awesome. 4x plus 1, I subtract 1. I get 4x equals 31 and x equals 31 over 4. If this is greater than -1/4, I will just say yes and move on. I no longer have to check because I stated the domain. If it's not greater than -1/4, I'll say no solutions. So what is the answer for this? Is it a yes or no solutions?
Yes.
Yes. 31 over 4 is a number greater than -1/4, and this is the solution, and you're done. You don't have to go back and check. That's the only difficulty, I would say, with log equations. Either state domain, or you say, no, I don't want to state domain, but then check. Back in the original problem. Up to you. I will not enforce any of the rules, but you have to do one or the other.
So how do you know if to check?
I'm sorry?
How do you know if to check?
How do you know if to check?
Yeah.
You must check. If you don't state it,
But the only way to really check is with the calculator.
not necessarily.
So if you say you need the whole.
Not necessarily. In this particular example, it's not going to be difficult.
Well, not this one.
So 31 over 4 times 4 is 31. 31 plus 1 is 32. 4 to the 5th is 32. So it's not. In other situations, it will be more difficult. But in this particular one, it's not. So it's up to you. You don't have to state a domain. I'm saying I will not enforce this or this. But you have to use one or the other. And you have to say, yes, I checked, or show that it's in the domain. Up to you. Whatever it's easier. Okay, so let's continue with 69 on the same page. And this is log base 3 of x plus 6 plus log base 3 of x plus 4 equals 1. Okay, so what has to happen for this to exist?
X plus 6 is greater than 0.
Perfect. What has to happen for this to exist?
X plus 4 is greater than
Awesome. So then this one, when I solve, is greater than -6, and this one, when I solve, is greater than -4. If it's not clear, just graph them, and we will decide where we see both colors. I'm going to use green for greater than -6, and I'm going to use red for greater than -4. The common domain must be where both colors exist, where both functions exist at the same time, which is -4 to infinity. When I'm done solving this equation, if I don't get solution or solutions that are greater than -4, what will I say about the equation? Awesome. That's it. So now let's condense this. How do I condense the sum of two logs in the same base? Where does this come from? From log base 3 of,
multiply them.
awesome, x plus 6 times x plus 4. Very good. Thank you, Kyle. Thank you, Stephen. Thank you for answering my questions. Very good. I have no clue how to solve this, but I do know that this can be changed into an exponential equation. Please dictate the exponential equation. 3 raised to, very good, 3 to the first power equals,
X plus 6 multiplied by x.
I'm going to multiply it, x squared plus 4x plus 6x plus 24. Now I'm going to ask myself, what type of equation is this? And how do I solve it? Quadratic. See why we repeat it all the time. Yes, it's quadratic. What do I need to do?
You didn't want to combine them. So, don't you
Of course I will combine.
Such
Absolutely,
a
correct.
normally know that that's for foiling things.
So then we have x squared plus 10x plus 21 equals 0. Very good. It is quadratic. Awesome. Well, I'm sorry?
2 - 3.
Oh.
We have four methods. We have 4 methods of solving quadratic equations. We have completed a square. Never. We have taken square roots. Not set up for that. We have quadratic formula or factoring. Good. I agree. So let's do that.
X plus 7 x plus 3.
Awesome. So then we are using the zero product principle, and we get awesome and any questions? Any questions?
So that would be the answer. Would be
That's it?
X equals -7.
That's it. No.
Oh, -3, sorry.
That's it. Or you go back and check. It's up to you. If you write a domain, you will not go back and check. There is no point. If you don't write the domain, then you must go back and check. Okay? Let's look at another example. What about 75? Not too bad, are they?
The page, same page.
Same page, yes.
Why do you,
I'm sorry, say it again.
why do you have x minus 7 and 7 more?
Say it again.
Why do you have x minus 7?
Because of the domain. Look at the domain. -7 is not in the domain.
You have more common domain?
-4 to infinity. -7 does not belong. Very good. Okay, so what is the condition for the first one, please?
X minus f(x) greater than 0.
For the second one?
Minus 4x greater than 0.
Awesome. For the last one? Well, what is it applied to? It's exactly the same thing you.
X minus 0 is greater than 0.
Very good. So the first one says greater than 6. The next one greater than 4, and the last one greater than 0. So we can graph if you want, but here's the idea. Greater than 0, greater than 4, greater than 6. And I need 3 colors in there. One more time.
6.
Exactly. Greater than 0, greater than 4, greater than 6. Where do I have all 3 colors?
6.
Right. Do we see that?
Oh, sure.
Is that clear? So if the solution or solutions are not numbers greater than 6, we will not accept them. Agreed? Okay, perfect. So now please tell me how to condense this and write 2. The 2 expressions with positive in front, where do they come from?
2 raised to 2.
They come from the top. The expression for the log that has minus in front, where will that expression come from? Good. So then we have log base 2, and now you'll tell me what to write at the top and what to write at the bottom. Well done. Very good. And the denominator? Very good. Let's review this one more time. This is very important. So 2 quantities in this expression of log expression, 2 quantities come from the top. They will have positive in front. This expression inside log comes from the denominator. It will have a negative in front. Is that okay? Is that okay? So now this is equivalent to an exponential equation. We always start with the base. And we go counterclockwise.
2 raised to 2.
Very good.
X minus
This whole thing. And I'm going to multiply the top. X squared minus 6x. There is not enough room there. Sorry. So 2 squared equals x squared minus 6x minus 4x plus 24 divided by x. Now, what type of equation is this? And we cannot say quadratic. And we cannot say radical. It is. Awesome. Well done. Thank you. It is rational. It has a fraction. And it has x in the denominator, of course. Thank you. Well done. Tanaya, right?
Mm-hmm.
Thank you. Okay, so this is 4. So I have 4, and this is my hint for you. That's your hint. What am I hinting at? Thank you very much. Well done. I cannot beg you enough. Please redo all tests with solutions every weekend. There are only 5 weeks left. Every weekend. And I have an error in the solutions. The scanner took 2 pages at once, and 1 page didn't get scanned. So I'm going to repost. One of the students emailed me. Page 2 is missing. So I'm going to scan them again. But you have the rest. So do the rest, please. I don't have them here, so I'll scan them tomorrow morning. So then 4x equals x squared minus 10x plus 24. So x squared minus 14x plus 24 equals 0. Very good. It's a proportion. It's a rational equation. So we subtracted 4x from both sides. We had to set it equal to 0. And I'm hoping that it doesn't take too long to factor. If it takes too long to factor, just go ahead and do the quadratic formula. That's fine. Yes?
X minus 12, X minus 2.
Very good. So then we have x equals 12 and x equals 2. Big question mark. Why? Good. Which means? Yes, correct. Very good. Awesome. Let's look at one more before we look at word problems.
Oh, shucks.
Let's take a look at 89. Or maybe 92. 92. Natural log of x minus 5 minus natural log of x plus 4 equals natural log of x minus 1 minus natural log of x plus 2. Let's take a moment to copy it down. So natural log of x minus 5 minus natural log of x plus 4 equals natural log of x minus 1 minus natural log of x plus 2. Can anyone give us the domain of the first function? Very good. Awesome. X minus 5 must be greater than 0. Perfect. Next. And always remember, when you are given a log function and you are asked to find the domain, this is what you have to do. So I'm hoping that this will help you in remembering. Okay, the next one. And x plus 2 greater than 0. Awesome. The first one says to the right of 5, then to the right of negative 4, to the right of 1, and to the right of negative 2. Think for a moment and give me the common domain. You can graph it if you want.
5.
Yes, indeed. Because it's negative 4, negative 2, 1, and 5. Is that clear? Do we need to graph it?
What was the answer?
Greater than 5. Agreed? Okay. Let's condense the left-hand side, please. Say it again. But what is the operation between the two? It's subtraction. So what do I write? Very good. What about the other side? Now wait for a moment before we look at this, just for 1 second. Let me refresh your memory on something. When we solve this equation, how did we think about it? We said this. Two numbers are equal and they have the same base. Therefore, their exponents must be awesome. Now, bear with me. Two logs in the same base are equal. What has to happen to their expressions, the expressions we apply log to? This particular situation does not require us to change it into an exponential equation like we did here. This one, we said 2 squared equals all this. It was rational. We cross multiply. This one, it's easier because I can do exactly what I did here. Two numbers are equal. They have the same base. The exponents must be the same. Two logs in the same base. If they're not the same base, it's a different story. Two logs with the same base, base e, are equal. Therefore, these quantities must be the same. This one on the left cannot be 5 and this one 3 because natural log 5 will not equal natural log 3. So that's why these two must be the same. So then we have x minus 5 over x plus 4 must equal x minus 1 over x plus 2. How do we address this? What is it? And how do we proceed? Perfect. It's a proportion. It's a rational equation, but a special one, proportion. So we will have to cross multiply. Very good. See how much you learned this semester? I'm very proud of you. So x squared plus 2x minus 5x minus 10 equals x squared minus x plus 4x minus 4. Take a moment and multiply. So x times x is x squared, x times 2 is 2x, negative 5x times x, negative 5 times x, negative 5x, negative 5 times 2, negative 10. On the other side, x times x is x squared, negative x, positive 4x, and negative 4. X squared with x squared, when I subtract, they go away. Negative 3x minus 10 equals 3x minus 4. Negative 3x minus 10 equals 3x minus 4. I move, so negative 6x equals positive 6. Therefore, x equals
Say that again. Go back in. Oh.
So what do we conclude? No solutions indeed. Thank you. That's awesome.